the purpose of this video is to compare a direct drive winch to a winch that has a gear ratio of 2.5 to 1. That means it has less speed but more power, and I'm gonna see which one can lift a heavier weight. I'm expecting the one with the gear ratio of 2.5 to 1 because it is supposed to be stronger, but I'm gonna keep lifting heavier and heavier weights until one fails. So today I am gonna tell you about gear ratios. I made this this pulley. The gear ratio is 2.5 to 1, and you can see it goes from a small gear. It goes from a small gear to a big gear. That is 2.5 to 1, and that means it goes slower, but it has more power for the motor to lift stuff. On my car video I got the gear ratio reversed, so when it was actually 2.5 to 1, it was 1 to 2.5. So right here I have a water bottle. It's filled enough to weigh 700 grams. So this should have more power than this last one I built. You can see this one, it was a direct drive. It didn't have any gears on the outside. That's called direct drive. So this should be more powerful. So let's see if it can lift it. It's getting there. It's quite slow though, but that's understandable because the gear ratio makes it slower. I'm hoping in the next videos I make to make this lift something even heavier. Let's try to lift it up. Ooh, it's straining a lot, but it can do it. So now this is a kilogram on the bottle. You can see it's a kilogram, and this should be able to lift a kilogram because the last one I did was 900 grams and that was fine. So it should be able to, but we'll show you. Ah! Whoops. It seems like it can lift 1 kilogram. That's impressive. So this is 1 kilogram. I tried it on that one with the gear ratio of 2.5 to 1, but this one has direct drive, so I'm gonna see if the direct drive can lift it. You can see that this crossbar here is going like this. So the direct drive can lift it, surprisingly. So you can see I have the same setup. Now, instead of 1 kilogram, this is 1 kilogram and 200 grams, so 1,200 grams. So This is the heaviest load it's ever done, and it's pretty heavy. So let's see if it can do it. It's doing it! It's going! You can hear the motors working at its hardest. You can get that. You can get the gear ratio by measuring the diameter or counting the amount of teeth. Okay, this spool isn't the greatest because it keeps going from side to side and takes up the room there and makes these ends fall off, but that's fine. I just have to make it go in the middle. Uh-oh. Uh-oh. You can see these ends have popped off because it has a lot of load. Ah! I think that might have been too much weight for it. So you can see I modified this one slightly. That's because earlier the direct drive one smashed apart. So I wanted to make them more similar so the experiment could be fairer. So I made this one as much like this as I could, but since it doesn't have gears, I couldn't make the axle in here like this one, so I had to do it on the side. And yeah, I wanted to make it more similar so it was a more fair experiment. So I'm curious if this one can lift it. But first I'm gonna show you this one. This is still 1,200 grams, but since this is slightly different, I want to see if it can lift it. And then I'm gonna show you that one. Yeah, you can lift it. That's good. So let's see if it can lift this. Something tells me that it can't. I just want to see maybe the forces are going in the wrong direction for where it's attached to. So I'm just going to keep this end up and see if it can lift it. Do you think that counts? I don't know. I don't think this can lift anymore. So I think that proves that this one is stronger because both this design and the last design fell apart. In conclusion to this video, we compared the one with a gear ratio of 2.5 to 1 to the one with direct drive, and we saw which one was stronger, and as expected, the one with a gear ratio of 2.5 to 1 was stronger because that gear ratio makes it slower.